network. This is the VNet, new VNet. It's named as new VNet. It has this IP prefix. That's the range of our IP address, and it has created the subnet as well. My backend subnet, and now it is stuck at public IP creation. Let's hit enter and continue. Happening or not? Okay. Now it's going to create the public IP address, and that also succeeded. See how easy it is compared to the steps which we follow on Azure portal. But when can you do this? When you know the fundamentals, when you understand the basics, what are the mandatory fields you have to provide. So what now in this one? Tell me what is the mandatory field we have to provide. We have to change. Now this is just a command. We have to provide the name, the VNet name. We have to have this resource group created already in order to run this command, because every resource goes on into the resource group. And you also have to make sure that you select the right location. And for VNet creation, you have to specify the IP range, and you're creating the subnet. Right? There's a my AG subnet. There are two subnets created. There's my AG subnet created along with the VNet, and there's another subnet created, my backend subnet, under the same VNet, and there's a public IP address created. So if you go back to your whiteboard, there's one more subnet created along with the VNet creation, and that's the name of that VNet is. Oh, sorry, subnet is my AG subnet. So it's I'll just name it AG subnet, right? And the subnet is 10.0.0.10. So this is the subnet range 10.0.0/24, right? So it makes your life much more easier deploying these resources through the command line. But you have to understand what commands you're running and what are the mandatory parameters you have to provide to succeed on these command lines. So there's a quick way of doing it. This is how when it comes to large deployments, it is always preferred to deploy Azure resources with the help of infrastructure as a code tools. There are many tools available. From Microsoft itself, there's the ARM template, ARM template, Azure Resource Management template, which you can build. You can literally code your whole infrastructure and just execute that ARM template to get your whole Azure environment ready. Or you can use some other tools like Terraform and Bicep. So these are the different tools available for doing the infrastructure as a code. So you can develop and build your whole infrastructure as a code, as you're developing an application with the help of code, right? So now we have the next action, which is basically creating an application gateway, right? So we have prepared this environment to deploy this application gateway here. So use network application gateway create to create the application gateway named my app gateway, right? When you create an application gateway using the Azure CLI, you specify configuration information such as capacity, the SKU size of the application gateway. It comes in different sizes, and HTTP settings, application gateway is assigned, my AG subnet, and the public IP address, what we have created earlier. So now we are going to create the application gateway. Look at this commands now, what exactly it is doing. So this is the name of the application gateway, my app gateway. It's created in each US location, and this is the resource group it's going to be part of. And this is the virtual network in which it will be deployed. And this will be the subnet where it will be deployed. The capacity, the size of the SKU is 2, standard V2. HTTP setting cookie based affinity disable. I'm not going to explain what exactly this is. This is mostly related to cookie settings for your websites. Front-end port is 80. So your application gateway is similar to the load balancer, what we did yesterday. So it will be the front end. That means it will receive the website request on port 80, right? And it will then send that traffic to the backend servers. So HTTP front end port is 80, HTTP setting port is 80. Protocol is going to be HTTP, and it's going to use this public IP address which we have created already. And this is the priority of the rule which it is creating, I guess. So on whiteboard, if you go to the whiteboard explaining this, let me do one thing. I will switch between the whiteboard and so we need this lab and the whiteboard here. Okay. Now I'm going to create an application gateway. Let's put it here. Let's say this is our application gateway, app gateway. This app gateway will have again configuration like front end IP. That's we are going to use this IP address what we have created. This will be attached to it, and it will have a backend configuration. And backend VMs are going to be in this subnet. So we'll be deploying the VMs as well, multiple VMs, VM1, VM2, right? So on the application gateway, again, what are the configuration you have to do? If it is an application gateway or a load balancer, you have this configuration. So for deploying the application gateway, you need to have a front-end IP created, front-end configuration, which will be basically the public IP address. You'll have to have a backend pool configured. Will be the pool of servers, your backend servers. And third, you'll have to have the rule created for load balancing. So how you want to do the load balancing. These are things, these are the basic configuration steps required in order to deploy load balancer, Azure Load Balancer, which we have seen, or the application gateway. So this is what we are doing now. We are deploying application gateway, and this application gateway is actually part of this subnet. So it is going to be deployed in that subnet. So let's move it from here. So the application gateway is this subnet is particularly deployed for application gateway. So this is it is going to be part of this. This application gateway will have front-end IP configuration. Will have backend pool configuration, and there will be a rule created for it. Right. So this is what we are doing now. So look at this. We have already created this my AG public IP address, right? In this exercise, in this task, we have created my AG public IP address. So we're just going to use that, assign that to the application gateway. So now we're going back to the command line and executing this command. This might take some time. Let's verify our Azure deployment so far, whatever we have done. I'm going here. There should be a virtual network created already, my VNet, and this should have two subnets in it, right? These are the two subnets, my IG subnet and my backend subnet. So these are the two subnets we have created so far, and now we are going to deploy the application gateway itself. Now, where will be the placement of these products in real-time scenarios? I'll just give you one high-level diagram here. If it is an on-prem scenario, on-prem setup, you might be having the router, which is provided by the ISP, might be the ISP router, and usually you will have a firewall. After the firewall, you will have your network. The network will be again divided in different rows in the real time. You have the firewall. You will have something called DMZ zone, okay, and you'll have the internal network, trusted network. You can also call it as a trusted network. That means that's the network which is managed by your own managed within your own network infrastructure. So this is now where is the place where we deploy the load balancers? Usually in this scenario, since the load balancer is acting as a front end, right? So it should be deployed within within the DMZ zone. So the whether it is a load balancer or application gateway, so it will be part of your DMZ. So this can be a load balancer or application gateway. And if you're talking about on-prem scenarios, there are products which comes with both the functionalities, load balancer as well as the application gateway. The both are same in terms of functionality. The difference is LB only deals with layer 4, layer 3 and layer 4, whereas application gateway has intelligence on it understands the layer 7 applications. So it can do the routing based on the URLs, based on the data, the content of the URL. So we have seen that, right? So what will happen? You will have the front end and you will have your web servers as well. This network and the DMZ network. Let's say this is my web 1 and web 2. So your front end, your load balancer will be receiving the traffic from the users. So if I'm the user sitting on the internet, accessing your site, abc.com, for example. So after getting the name resolution done, after it gets the IP address, that IP will be actually assigned on your router or the firewall. And this firewall will perform something called NAT, network address translation, right? So the public IPs, the firewall actually distinguishes between your trusted network and untrusted network. So we'll be seeing the firewall also today. So it treats the internal network as trusted and external network as untrusted network. Untrusted network. Okay. So it segregates the traffic, the interfaces. So in real-time scenarios, in the on-prem setup, you'll have the firewall. The firewall will do the NATing. What does the NATing means? NAT is network address translation. So it translates your public IP to private IP or vice versa, depending on the scenario. So in this scenario, it will be a public IP to private IP conversion. So let's say my website is having the IP address. Uh, let's say my IP is 10.2.3.1. For example, this is the public IP. So this public IP will be actually routed towards your firewall. Your ISP will know that this IP is owned by you. The moment it comes here, you will have this IP 19 NATing will be there on your firewall 19.2.3.1, And on the firewall, you will say, okay, for this IP address, this is hosting my website. So this should go, this should be added to the LB load balancer. So let's say I have a private IP assigned to it, 192.168.1.10. So you will have a netting done on the firewall saying that this public IP should be netted to this IP address. So the traffic will land here on the firewall. Firewall will do the netting and it will reach to your LB. Now the LB load balancer knows that it has a backend pool configured, and that is one of these. So it can send the traffic to one of these servers, and then your application servers, the front end servers, the web servers, will have the backend servers in the trusted network. That can be your SQL server. So this is how the load balancers are placed and deployed in the on-prem scenarios. They're not directly exposed to the internet. They are deployed in a safe zone, which is called a DMZ network. Right, DMZ itself means demilitarized zone. So only the applications and servers which are required to be internet facing will be deployed in the DMZ zone. So here in Azure, we are directly assigning the public IP address to the front end, to the load balancer or the application gateway. You can also replicate the same scenario. You can also have this similar setup as you're doing on-prem. You can deploy the firewall first, then have your separate zone for application gateway or the load balancer. So this is just for your understanding how the load balancer or application gateways work on-prem scenario. So let's see, our application gateway deployment is still happening, taking pretty long. Okay, let it do that. Meanwhile, we'll see what is next. Okay, it may take several minutes. Yes, it is already said that here. Application gateway to be created. After the application gateway is created, you will see these new features. App gateway backend pool. An application gateway must have at least one backend address pool, which is same as the load balancer. Otherwise, there's no point deploying that. So you are actually trying to load balance the traffic, right? Here you're trying to load balance the traffic based on the application. App gateway backend HTTP settings. So specify that port 80 and HTTP protocol is used for communication. So from the load balancer to the backend server, which will be your web server, it will by default communicate on port 80 unless you change it. You have an option to change it. Then you have app gateway HTTP listener, the default listener associated with the application gateway backend port. App gateway frontend IP, you are assigning the public IP address to the front end configuration. And then you're also creating a rule, the routing rule, the default routing rule that is associated with the application gateway HTTP listener. So after this is being done, yes, now we have the application gateway deployed. You can see that is completed and it has succeeded. Let's look at the application gateway, how it looks on platform, Azure platform. So, application gateway, right? Here is our application gateway deployed. You can see that I told you yesterday, it's the same blade on Azure, which you use for managing the application gateway and the load balancer. And this is the application gateway, and it has this public IP assigned as a front-end IP, public IP address. So your website should resolve to this IP address. If you're having a DNS configuration done, when anyone types your website name, abc.com, should be resolving to the front-end IP address of your application gateway. And it will connect to your application gateway, and application gateway will route the traffic to your backend server. So let's continue with the setup. The application gateway is created. Now we have, I'll show you. we're creating the virtual machine scale set. So let's look at this. So while creating this, it says the size is not available. I think Ubuntu is not available. Ubuntu, get it there. Ubuntu size of the VMs. Let's use the size. I just want to see what is the default size it picks, so we can probably make use of that. Okay. Create virtual machine scale set. Resource group, my resource group. Okay. Name VMSS. On. Okay. With two instances, this is what we are mentioning. And image size. Ubuntu. And it is selecting this size. Yes. Try to use the size. What I'll do is now I'll copy this. This is like that. This is the command. Let's try to change the size of the VM as per this. Let's try this. Oh, it was the same size, right? Standard DS2 D2S. It was a AS. It is AS. It's different, little different. I think we have to give underscore B. Okay. What happened? Okay, it's not recognizing this size. Let's try to create it from here, and we'll see the commands what it is using. VMSS one. Okay, right. Let's flexible. We set two instances. Azure username password. We'll use a password to insert. What is the username it is using? Azure user. Password. All right. And let's review and let's see review. It will validate the VM size and all the parameters. Okay. Right. Okay. Validation failed. Says virtual network. My email. Let's do this. What is missing? My unit nick, load balancer none. Okay. Okay, validation passed. So it is using the size Ubuntu version this. The size is this. Can we create this or download as a template? You can see here, there's an option here to download this configuration as a template. Let's look at the template. I will get some idea on what parameters we have to change. This is a template now. Variables, resources. How we can download this? Download. Let's not give it up because this is how you learn. We'll see what are we missing here in this command line. We see that there was an issue with the sizing. So this is the script. It's the same way what we're doing. This is the ARM template which Azure creates. So let's look at the virtual machines, and it is using this size. Let's try to use this size now script. Okay. The size standard. Right. So we got the size corrected. What else we need from here? And that was error, right? So let's try doing it now. We have not created that resource from total. So now let's try doing this again from the CLI. Default value of will be changed to this size. Fine. Accepted. So you can see now the configuration is accepted, and we are going to have the virtual machine skill set created. That will create two virtual machines. So this is how you need to figure out what is the issue. So if you give up now, you will not be able to do it later. So just try to understand. So what I've done, I've just seen from the portal, trying creating the same resource and see how it is scripting that configuration. So we were giving the wrong parameters in the sizing. I just picked up the sizing from here. So let's see if this gets created. It is accepted. It should be getting created as well. And after that, what do we have? After creating the virtual machines, and the next step we are going to solve the NGINX. Now, what is NGINX? Yesterday we have seen setting up the web server on Windows machine. And what was the application we are using? We were using yesterday for making a Windows server as a web server. I want to hear from you guys. So yesterday we have set up a web server, right? Using the Windows operating system, Windows server. And what was the application or the service which we installed? Make this as a web server. Your server operating system, the moment you
IIS.
exactly IIS. That is a web server application which turns your Windows server to web server, and you can configure and host your website from this. Now, what we are doing in this example, we are going to run the web server on the Linux operating system, and on the Linux operating system, now my web server is going to be on Linux, right? On the Linux operating system, I am going to install NGINX. This is one of the application, one of the web server application which you can run on Linux operating system. It's not the only one. This is one of them, right? So that's what we are going to do in the next exercise. All right. Congratulations. Your virtual machine skill set is created now. So we have nailed it. We created the virtual machine skill set from the command line. Now we are going to install. It is just a plain Linux server, right? So the virtual machines which we have created, VM1 and VM2, are just the Linux operating systems and running. Now on those Linux operating systems, we are going to run and install the NGINX, which is the web server application for Linux environment. And that's again, we are going to do that with the help of Azure CLI. And let's look at the commands again, what we are doing. We're using custom script here. There's a script that will download. Where it is downloading from, let's see. Virtual machine skill set, settings. This is the link, okay, from GitHub. It is downloading this NGINX application and it is installing it, right? So let's do this now. For this, we have to make sure that Linux virtual machines are already created or not, and they're up and running. Let's look at the virtual machines now. Should be a virtual machine skill set actually, what we have created. Yeah, so you have two virtual machines created as part of the virtual machine skill set, and they're both running. They're running the Linux operating system and they're both running. We can even access and check this if it has the public IP address assigned, which is having any public IP. There's no public IP. See, we have not assigned any public IP to this virtual machine, and we do not have a Bastion host configured. So there's no way you can log into this virtual machine directly now and manage it, right? So what we are doing, we are not even logging in. We are just trying to install the Linux NGINX through command line. Now here we have the error again. Fail to parse string JSON. What is happening here? Valid JSON file, path or JSON string. Okay, I need to see what it is. Probably because this lab is pretty old. This might not exist. This link might not be valid anymore. So that's what I'm looking at now. Let me just figure out what it is. We'll get back to this. Just few minutes. Then, if it doesn't happen, then we'll continue with the next things. Not just waste time on this troubleshooting. But it's again, as I told you, it's part of your learning. I just need to Google this and see what exactly is this error. Just bear with me. I'm sure stop sharing this for a while. Just 2 more minutes, guys. Sorry for this. I'm just checking what is wrong with this command line. Then we'll be back on the session. Okay, I'm going to share the screen again. It is still failing. I'm not sure what parameters we're missing here. So let's do one thing. We'll try to run this uh, on the CLI Cloud Shell CLI and see, because this exercise is meant for Cloud Studio. So let's do that. I'm sharing the screen again. So what I'm going to do now is copy this and go to the Cloud Shell CLI. What else we have after this? Uh, Only testing the application. Okay. So we are almost done with the lab. So we have seen, I hope you have learned something. Creating these resources from the Azure CLI command line. We can troubleshoot these issues, but again, it will, consume our time, and we don't have the luxury of time. We have many topics to be covered. So let's try Azure Cloud Shell. I'm doing that, and it seems to be running. So there's a syntax. There must be a syntax error when you're running this script from the Azure CLI, which is running on your machine. So hopefully this will install the web services, the web server, NGINX web server on those virtual machines. Okay, this might take a while. Let's look at the next step. So after the NGINX is installed, to get the public IP address, now we are going to test, we need to test the application access right, and that will be through the public IP address of the application gateway. So how do we get, it shows you how you can identify the IP address from the command line. AZ network public IP show. So this will basically show you the IP address of the application gateway which we have deployed, or the easy method is that you can straight away go here and look for the application gateway which we have deployed. Application gateway. Okay. And here we have our application gateway. Okay, my app gateway. And that is your public IP, right? So you'll have to use this public IP to access the web server. It says all the instances in one or more of your backend pools are unhealthy. This will result in file2 error. So this is what the application gateway is doing. It's checking the health of the virtual machines. So far, we have got the virtual machines created, but it is not running any web application, right? So your application gateway is already in action. It is checking the health of those two virtual machines, saying that you don't have the backend pool healthy, and the users might get the error file2. That makes sense. We'll just get the IP address here. Once we have our web server ready, we can try accessing it. Okay, so here, just put this IP. And this is taking a bit longer here because it has to install the application, the web server application. Right, so that's once we test that, that's the completion of the application gateway lab. So can proceed with this next steps. It doesn't finish doing this job in 1 or 2 minutes. We'll continue. Let's continue with the slides. Let it take its own time because it's installing the application on the servers, and we just have to test that once it is done. We'll continue the slides now. Right. So application gateway, you can do the routing. You can define different routes based on the content of the application, images, videos. You can redirect or route it to different servers. You can do site-based routing as well. If you have multiple sites and you have different servers, running those websites, you can redirect them on different servers as well. Now, what is the Azure Front Door service? Azure Front Door service improves your website's performance and availability. This is what you read here. By routing global traffic through the fastest path and instantly switching to another region if one fails. So again, you can see that it's a kind of fail load balancing again and failover mechanism. What it does is I'll show you. We have, I'll just draw a diagram here. We have front door. There's a front door lab as well, and that has a diagram also in it. I'll explain it from that. Machine, input. Now you're using something called Azure Front Door service. Okay, this is a service which you will configure to load balancer. Now here we are configuring the backend pool in different regions basically. So when your user is accessing the site, the traffic will reach the front door service. It will have the public IP assigned. Okay, it will have all the routing and configuration. So this will have again the front end IP, the backend pool configured, and the rule for routing, and you can also activate the web application firewall. So this will do all of that. The front door service, it's a service, and it will do the load balancing based on different regions. So again, similar concept. The difference is that the application gateway is regional and the front door service is global. This is what this image shows you here, right? So you are distributing the traffic to central US and the east US. So you can have regional based failover and the load balancer. So this we have an exercise again. We can do that. Let's look at what happened to our existing one, the previous one. Oh, the NGINX failed. Something failed here. So VM has reported error. It should be request failed. This might be the issue here. This is for NGINX. Okay, so we have some problem with this lab. Actually, this script the might be outdated, which we have in the lab. So we can't really test it. So otherwise, you have seen the process. You know how to do it. Now, instead of doing installing NGINX through the script, you can log into the virtual machine directly and install it. So what do we have to do for that? I want to log into each virtual machine and install that NGINX application. What should I do? You have to tell me what steps I have to take for that. Anyone? I need to set up my virtual machines which I've deployed as part of this exercise. I need to log into each virtual machine and install NGINX. So you have seen that we have not enabled the public IP access on this virtual machines, and we do not have the uh, Azure Bastion also deployed to our virtual network. So these two options are out of the scope now. Now the third option could be if you have hybrid setup and from your on-prem network, if you have access to this virtual network, you can access these VMs, log into these VMs, virtual machines, and install the web application. That's the third option you have. Even that is out of scope because we don't have any hybrid setup. We don't have on-prem scenario. The last option which remains is setting up the VPN, right?
VPN. Yeah,
Yeah.
VPN.
So if you have set up VPN on Azure, client to site VPN, you can install the VPN agent on your machine and connect to Azure Virtual Network and install the application on these servers. So we don't have the VPN configured as of now. We'll be seeing that in the next exercise, right? So let's continue with our next exercise, front door service. So I just want you to understand the concepts here. That's the most important thing. What is the difference between these different load balancers? This is layer 3, layer 4 load balancer, the Azure load balancer. Application gateway is a layer 7 load balancer, which can also have the WAF activated web application firewall. And front door, Azure front door is the global load balancer. So these two are regional, which are deployed in a specific region. This is global service. So let's look at this scenario now and see if we can do that exercise. And quickly, I will show you what we are going to do in that exercise here. Let's close this one for now. I'll clear that setup. We'll start, charging for the VMs which we have created, or we can keep those VMs. When we deploy the what is that? The VPN, we can connect to this VMs servers and install the NGINX. So I'll just shut down the virtual machines. I'll go ahead and shut down these virtual machines. See an option here. Okay, start the virtual machine, yes. And this one as well. Okay, while it is doing that, we can continue the next service, Azure front door. So what does it do? In this lab, in this demo, what we are doing is create a front door for high available web application using the Azure portal. Right, in this exercise, you will set up Azure front door configuration that pulls two instances of web application. Now, this is slightly different. You will learn something new again here. It's not the same thing which we are repeating over and over again. Instead of the virtual machines, we are setting up the web application. As I told you, uh, you don't really need a virtual machine. If you're just deploying the web server on Azure Cloud, you can make use of web application, which is a platform as a service from Microsoft. So you don't really need to build the virtual machine and install the web application server and set up that web server. Instead of that, you can go ahead and use web application and just upload your data and the content of your website to that web application. So now what we're doing in this, we are going to use Azure Front Door service. We're going to deploy web applications that runs in different Azure regions. This is the key difference, as I told you. If it is within the virtual network and the same region, you won't be using the front door service. It's only for the global load balancing. You'll be using it. This configuration directs traffic to the nearest site that runs the application. Right. This is the advantage again. It's load balancing as well as for faster access to your websites. So it will automatically redirect the users to the nearest region. If the user is part of the central US region, they are sitting in that area, that geography, they will be redirected to this web application, not to the East US or anywhere else in the world. So Azure Front Door continuously monitors the web application. Again, this is like a monitoring of the backend servers, which we have seen in the load balancer and the application gateway. You will demonstrate automatic failover to the next available site when the nearest site is unavailable. This is the high availability concept of what we have seen in the load balancing, right? We created two virtual machines, made two web servers. We shut down one of the virtual machine, and we have seen how the traffic is load balanced and made highly available with one single virtual machine running. Okay, this diagram gives you the idea what we are going to do, and these are the exercises we are going to perform. Task one: create two instances of web application. This is something new. We have not discussed web applications. That's mostly next weekend. We'll be addressing web application containers and Kubernetes also. So create a front door for your application. View Azure front door in action. So let's do this exercise. I don't need to draw it. Actually, we have the diagram very simple and clear. This is what we have done. Otherwise, if you still need the explanation on the whiteboard, I can do that. But here, what we are doing is, in the first step, we are going to create the web app. For the web app, you see that we are not creating the virtual network as such. Like for example, when in the previous examples, for creating the virtual machine, you have to prepare your whole infrastructure, right? You have to create the virtual network. You have to create the appropriate subnets, and based on your design and the deployment requirement, and then you deploy the virtual machine. So here, web applications. These are again platform as a service. This is again platform as a service. Both the services are considered as a platform as a service from Microsoft. So these are not the infrastructure components which you are managing. Microsoft is managing this web app also. You're just consuming it, you're just configuring it. So let's do this now. I'll go to the lab. Okay, so we have made this VMs turned off. Yes, stopped. It will stop billing on this too. So we'll do the front door now, front door configuration. So we go, let me close this. Web app services, create a web app. Okay. Under the app services, we are going to create. We have different options here. You can see you can just create a web app. You can create a web app plus database. You can create a WordPress on app service. So this represents your web server, like we have been seeing in previous examples. Creating the virtual machine, deploying the IaaS service or on Windows Server or the NGINX on Linux server. So make sure to make that as to make that server as a web server. And we have seen multi-tier architecture of the application and web application. Mostly you will have the web front end and the back end. So the same thing you can replicate here with the app services. You can just create the web app, the front end component of the web server, or you can also have web app plus database, the front end and the back end, both on the Azure platform itself. So let's create the web app. Create web app, go to the basic settings. Now we're following all the configuration here. So this is a subscription. We are going to create the resource group here with this name. Create new. Okay. enter a unique name for your web app. So it has to be a unique name now because this will be accessible over the internet. Let's see this, and you can see that it will be accessible based on this domain name. It randomly creates this name for you, the domain name, and you can use that to access the website over the internet. And publish, select the code. Okay, we are in the publish, we are selecting the code. Now you can see you have a container option here. If your web application is container based, instead of selecting the code, you can select the container. Okay, so let's continue code, and we are going to run use the runtime .NET. So my code, my website is developed in .NET application. So I'm going to use the .NET as a code here. When is that? .NET 8 LTS. Okay, and operating system. So .NET is mostly the Windows based applications developing tool. Right now, the latest .NETs work on both the platform, the cross platforms as well. So we are going to now host this on the Windows. See, this is not now this is the platform we are using from Microsoft. So this is platform as a service. We are not building and managing this Windows server. We're just deploying our application and choosing which platform you want to run that application on, whether it is a Windows or a Linux. Right. So in platform as a service, again, the when you look at the responsibility chart, responsibility of the customer and the cloud provider, it will, it will be half 50-50. So you'll have some responsibility and uh, the cloud provider will have some responsibility in maintaining that platform. So let's look at the operating system Windows regional. We are going to choose Central US. Okay, and Windows plan. We're going to use. We have not seen all these options before. This is the first time you're seeing creating the web app. We'll be discussing this later. So I'm going to use Windows plan, create new, and it is going to be this. It is going to have this name. We're creating a new plan here, and then pricing. We are going to select standard S1 pricing plan. We are going to select standard. You have the free plans as well. You can see for testing your web applications, you can create the free plan and test it. So let's look for this one. Now, earlier we were doing the virtual machine sizing. Now here we are selecting the application sizing. So based on your application need and the requirement, you will be selecting the size here. So mostly this will, your developers, if you're a developer, you'll know what specs you require for your application to run. So based on that, you'll be selecting the size. Standard S1. Do you see anywhere standard S1? Premier, Premier, standard S1, yes. That's the size I'm going to select. Okay. Review and create. Review and create. We're just deploying web application, not the database. Validation failed, basic tab, what happened? Okay, the name is not available. Okay, so we'll try to use something else. Uh, some random name. While if you're really deploying the web app for the production environment and for your organization, you will be having a registered name with in the DNS, and you can use that. So let's try using this. Oh, did I name it wrongly? Okay, Azure Bootcamp app. So this is passed now. The next step is basically create. Okay. So after that, we have some more configuration. On the create web app, we are creating one more web app. So we created one web app for several years, and I guess the second one we are going to create in ECS based on the lab. So this is what we're doing. We created this central use web app. Now we are creating the ECS web app. Okay, let's follow the procedure again. Okay, web app. Subscription resource group name, which we have already created. Resource group. What was the web app name we used? Azure at what? We have already the other name. I'm just naming it as Alpha. It has to be unique. Okay, and the code is going to be same. We're going to use the code and runtime .NET LTS, and it's going to run on Windows platform. We have to change the region to ECS. ECS. Okay, and we are going to create a Windows plan. We are going to use the plan. Right, and we are going to use the standard size again. S1. That's the size we are going to use, and we are to right. So this is going to be our second web app. You can look at the pricing. Estimated price is 43 USD per month, right? Which will be much cheaper than the virtual machine cost, which will be running. Okay. Now we have created two web apps. There's a message here. Note, if you receive a deployment error, read the notification carefully. If the error involves region availability due to quotas, try changing it to another region. We didn't get any error, I guess. Or we got one error here. What is the error we have? Cannot be completed with additional quota. Okay, that's the same error we have got. Exactly what it says. Try to change another region. So let's try to change the region now. .NET LTS Windows. So East US. Let's try the West US. West Central US. Okay. Not finding your app source plan. Tired of information. Okay. So it gives you the note here as well. So if you're not able to find a specific region which you're looking for, it is quite possible that the web applications are not supported on those regions. So that's the note here, and we're going to go ahead again and create a new plan. This is going to be West US, right? So let's name it West US. Okay. Right. And let's see if we have the quota available in this region. Okay, it seems this region has a quota available and is deploying our web app 2 now. Let's go to our previous load deployment web app and see if it is accessible. We can see that the first application which we deployed is available to be accessed over this link. Let's try accessing it. And you can see that the default web page is showing up. Your web app is running and waiting for your content. So if you have your website content, if you have website data, you can upload this to your web app and your website will be up and running. So this is very straightforward and simple way of deploying your web services on Azure. Let's go to the other second resource which we have created, second web app. And this has this name. And your second web app is also up and running. Okay, our web servers websites are actually ready. Not on those. We have not deployed it on our web servers, on our own servers. We have just used the Azure Web App Service to deploy our websites. The next step is basically deploying the front door service. So create a front door for your applications. So now we have two web applications. So in the real time scenario, if you are the web developer, you are the one who has to maintain these websites. You have to make sure that the content which you are uploading for your website has to be exactly the same. It should be synchronized between these two web apps. So when you're uploading the data, it should be same so that users get the same experience when they're accessing your website through the front door service, right? So that is your part of the responsibility. Now we are going to deploy the front door service. Configure Azure Front Door to direct user traffic based on lowest latency between the two web app servers, right? So to begin, add a front end host. Okay, let's do this now. On the Azure portal page, search for resources, services, and networks. Search for front door. Okay, you know that. You just go to front door. Look for this, and you have your front door service here. But it also tells you what exactly the front door means. It is load balancing and content delivery product from Microsoft. So now what we're doing is we are going to go ahead and create front door and CDN profile. So it is doing two things together, front door as well as the content delivery CDN setup. That means what is happening is that you are having your website deployed to do two different regions. So the users who are sitting in central US, they'll be redirected to the central US side based on the speed and the connectivity connection speed. Because they'll be the near this app, this region will be the nearest for them. So the other users will be redirected to the ECS who are accessing from different regions. So now Azure Front Door Service, we have here some alert. Azure Front Door Service Management restrictions have been lifted. Configuration propagation times may take 45 minutes. Okay, right. So let's carry on with this exercise just to see how front door is configured. We can do the testing later if it takes time. Right. Quick create, continue to create a front door. So we are going to use this option, quick create, continue to create front door. And then we are going to again select all the parameters which are required. The subscription, there's some error here. I think this subscription is not, it's limited. There's some limitation on the subscription. We can't use the front door service here. What about this one? Yeah. So there is there's some more. What does it read? Azure Resource provides some types. Okay, so this means that front door service is not available for our subscription, so we can't really deploy and test it. Okay, but if you look at this setup, the configuration is very straightforward, and in this you have learned how to deploy the web applications. The second task was just to create the front door and test that application. So you can see this is pretty straightforward. View Azure front door in action. So when you access once the front door is created, you will have your actual domain name assigned to it, not and the website, the backend services. For example, let me show you here where I'll be linking the web apps as a backend. Settings, okay. This is the front end of the front door service. And here you're actually giving the name of the web app you previously deployed. So your web apps can have any name assigned to it. That's not a problem. But you'll be linking the front door. The front door service will have an IP address and the domain name assigned. So this has to be your actual domain name, which will be your website domain. So that will be assigned to it, and the users will be accessing this front door and can see that your request might land on the appropriate what do you say web app based on your location. So you'll get the response from the backend, right? So that is what. So we have seen web apps. We'll see there are two web apps created from here. You can see that there are two web apps. One is in Central US and the other one is West Central US. So mainly, what is the web app? This is actually your web server. Your web application, only the application, not the server. You're not handling the server. Server is managed by Microsoft Azure. You're just worried and you're just responsible for managing your web application and the content which you are going to upload in this web apps. So that's how the web apps work, and that's kind of this lab. So we'll get rid of this lab, but we can't see the front door in action due to restrictions on the subscription. If you have created a new subscription, new account, you might be having an option to practice that. But on my subscription, I don't have it. Now I'm going to go ahead and delete this resource group. So I can do that from here on the command line. Okay, it's gone. So let's verify that. Resource group. What was the name? Contents of resource group. It is still there. I've not removed it. Okay, let me remove this from here right now. It is deleting the resource group. That's fine. Let's continue with the next topic. Next one is traffic manager. Now this is again another type of load balancing, but based on the DNS. We can see that Azure Traffic Manager is a DNS-based traffic routing service that directs user to the appropriate endpoint, but does not perform load balancing the data path. Right. So you can see the image. I will show you here. Traffic Manager decides where the user should go, not how the traffic is load balanced. So that's the difference between the load balancers and the traffic manager. In the load balancer, you are able to manipulate the data. You can you're configuring the front end and the back ends, right? And you can do the SSL offload. You can do the filtering, data filtering. You can do the routing based on the data. If users are requesting for the images, the traffic should go to different backend server. If videos are played, the videos will be stored on a different server and it will be routed and load balanced on the load balancer. But none of that happens on Traffic Manager. This is only the based on the DNS load balancing. So we'll see that in action. I'll just show you. We might not be able to see this in the lab, but I'll explain you here. Let's see. We have one lab here, Traffic Manager. What it says. Now there are different use cases for each of this solution. Why you're learning this? Because you should be aware of this solution which are available on Azure. So in order to administer, architect the solutions for your customers or for your organization, you should know what are services and the solutions are available from Microsoft. So this says again multi-region load balancing with Traffic Manager, Azure Firewall, and as Application Gateway. So this is deploying all three components here. There's a Traffic Manager, there's Azure Firewall, and Application Gateway. Right? Do we have any diagram here? Oh, this is a very complex network which we will be setting up, but we can't do that in the lab. This will at least take 2 to 3 hours. So you can see here what is happening. The traffic manager, the DNS load balancer is sitting here, and that is balancing the traffic. Sorry, this just redirecting the traffic based on the user location. Okay, so there are two regions here. These resources are deployed in two different regions. This is the East US region, and this one is what is this? This is the West US region. So you have this whole setup, and you have seen mostly all these components. You can see that there's the application gateway, right? That's the first component on your network, which is doing the application-based load balancing, and it is also having the WAF activated, Web Application Firewall. Then after that, you have a Azure firewall. We have not seen the firewall yet. You see that. And then there is a load balancer. There are two load balancers you can see. Just for your understanding, what the image what you're looking at, you know, I just want to explain you that. Let me see if I can write on the screen. Second. Let me take this image in the whiteboard. You can see that. It will be a very good exercise for you to learn all these components together. And it's a big exercise. You can see here what I'll just bring in that file here. Images. Right. So you can see, look at the items, different components deployed here. So this is the new component. We are discussing traffic manager. This is a DNS load balancer. So based on the location of the user, it will redirect the traffic to the nearest region. So if the user is accessing from this region, which is West US, he'll be redirected to this setup, this particular Azure setup. And if the user is accessing from this region, the other one, or the other one here, you have East US here, right? The user will be redirected here based on the location of the user. How is the location identified? How is your location identified on the internet? A question to you guys. You're sitting here in UAE and you're browsing the internet. How can someone on the internet, someone on some application or the service, identify you are browsing from which region or which network? Yes, anyone can answer. Can you answer this question? You're
Are we
connected
seeing
to
the
internet,
public
right?
IP?
Based on the public
I
IP,
think public
right?
IP.
So
Yeah.
you see, the public IPs are assigned, the range of IPs assigned to each region by IANA authority. You have seen that.
Yeah. Yeah. Yeah.
So you can see who is what is my public IP, what is my IP,
Yeah.
right? So you can basically see
Yeah. Sharjah. So.
this is your IP which you have got on public IP on your network, right?
Yeah.
So for me, it is showing Abu Dhabi as a city, but it's mainly the country is the concern. And you can
Yeah.
even narrow down to specific location with the help of your ISP help. They can pinpoint the exact location. Now, for example, me, I'm sitting in my apartment building, right? So
Yeah.
I'm having a specific connection to the internet. So from ISP, the ISPs can help the authorities to pinpoint the location and the account number. They can tell if they have proper information registered, they can tell you even the apartment number. Otherwise, they can at least tell you the nearest point, the building they can identify from where you are connecting to, right? The apartment block you are connecting from. So that's
Yes.
how
Yes.
you are identified on the internet based on your public IP. So Azure Traffic Manager identifies your location based on your public IP address, and it will redirect you to the specific region to have a better performance on the website. So you can see in this example, there are many things which are deployed. Second. It looks complex, right? But when you sit and design your network, when you understand all these different components, it will be very easy for you to plan and deploy these components. So we have seen how these components are deployed. You should understand the basics, the fundamentals. You can see that this is the application gateway, which is configured here. Now that application gateway is WAF is just a feature of it. This is an optional feature whether you want to turn it on or off. But it will have by default the LB layer 7 load balancing activated. So you have the application gateway, and then behind that you have Azure firewall. You can deploy the firewall for traffic filtering. Then this is your load balancer component, wherein you're load balancing the front end servers. These are your front end applications servers, web servers, right? And then again, this is a multi-tier architecture. This is what the multi-tier architecture means. This actually represents, you can see it's written here for each component what it is: application gateway subnet, Azure firewall subnet, internal load balancer. Now this is internal. Why? Because it is not directly having a public IP assigned. It is called internal load balancer. And then you have web tier subnet here, where you are deploying your virtual machines, which are having the front end web servers. Then you have another load balancer, and this is your business tier subnet, where you'll have the application servers deployed, right? And then you have your backend servers and so on. So this is how it you can see that this seems to be very complex network, but when you sit and design, when you understand each of these components, you can really fit together. It's like a puzzle. You should know which component fits where and how it is deployed and how it is configured. So that's why it is really important for you to understand the concept. And you can see we have also seen VNet peering, right? So you have these two different setups here. Azure in one region we have this setup. The similar setup is there on another region, and between these two VNets we have VNet peering configured. That means a virtual machine here can access the virtual machine here in this network over the Microsoft Azure Backbone network, right? So all these different components fit in together to give you the highly available application architecture or the infrastructure what you're building for. Let's continue with this. So let's look at what exactly this traffic manager demonstration shows us. Demo. We can't do this lab. I'll just see what we have here. So you have you're going to configure. Actually, this is not a lab. It's just giving you the explanation on how traffic manager will work in this scenario. So is there any lab? I don't see any labs here. There is a lab. Create traffic manager profile using Azure portal. And then 35 minutes. Okay, so you can see here. Uh, this is you have seen the similar diagram just before this, which was the front door service. Now here instead of front door, you have the traffic manager. Okay, traffic manager is load balancing the traffic based on the location only. It is not having any web application firewall. It doesn't have any front end and the back end. It's just based on the domain name. It is domain and the location. It will redirect the traffic to your specific region where you have the web service order. Let's look at this. Create the web apps. Create traffic manager profile. Add traffic manager endpoints. Traffic manager profile. Let's see if you can do this lab very quickly. And we are again creating the web apps, two web apps like we created before. for the front end load balancer. So this is not load balancer. You need to understand there's a difference. Traffic manager does not do the load balancing. It doesn't understand the load on each region of the service. But whereas the front end, it can see the load, it can balance the load across your services. We're creating two web apps, and then we are creating the traffic manager profile, and we're configuring the endpoints. Instead of backends, here we are configuring the endpoints. Those endpoints are nothing but the apps, web services which you have deployed. You can see that in the endpoints, we have two endpoints configured. There's the traffic manager profile. So we can test this. Basically, you should be testing it from different regions to see where you're landing on. If you want, we can quickly run through this lab, the demo. Otherwise, we'll continue with our slides because we have some more slides left, some important topics. I just wanted to understand the concept here. Okay. So it says here the key takeaways: Azure Traffic Manager is a DNS-based traffic load balancer. This service allows you to distribute traffic to your public-facing applications across the global Azure regions. Traffic Manager has six traffic methods that allow you to control how Traffic Manager chooses which endpoint should receive traffic from end user. Okay, you can how many you can name, it shares as you can nest traffic manager profile to combine the benefits of more than one traffic routing methods. Okay, these are key takeaways. We can quickly go through this. Doesn't seem to be very complex. Let's see if you can do this traffic manager profile before we break for our session. I'm going to quickly run through it because you already know what we are doing here. We are deploying two web applications like we just did now for the front end. Then we'll focus on this one, how we are configuring this one. I'm just going to run through this one and then we create the web apps. Static website, web app. Is this not deleted yet? Okay. Make sure you delete your resource groups after your labs, which are not required. Why do I have all this changes? Let me see that later. Is it time for break? Shall we break for it? It's almost 12:14 now. Let me look at the time, play times. Yeah, we can break in 5 minutes. There's still some time left. Let's create the lab now. You know what? Before doing the lab, we'll see what else we have here in the in this slides. Firewall, exit firewall, WAF, DDoS, exit bastion. I prefer to skip this lab, traffic management, because it's going to take long time. You guys can continue with this lab and see how it works. So I will continue with this slides, but we have too many slides, and I wanted to finish this slides today, this weekend. The labs you can do it offline, and if you need any help, you can always connect with me. So let's go through these slides, understand the concept and the service.
It's 12:15.
Yes, we'll break it the moment the prayer starts, we'll stop it.
Oh,
So there will be call to prayer, right? We still have 5 minutes in. Okay. So traffic manager, you have seen traffic manager load balancing is based on the domain name, the nearest location, based on the location it will do. And here is the quick comparison of these four services. All are similar in nature. We started with Azure Load Balancer, which does the load balancing based on layer 4 protocols, TCP and UDP, application gateway layer 7, but it is regional HTTP load balancing. And front door is the next version of it, you can say. It is a global HTTP load balancing. So both are similar. The only difference is this is regional and this is global. And both of this can have WAF, web application firewall, activated along with this configuration. Okay. And traffic managers based on the DNS. So choose endpoint via DNS. So this is the important point you need to understand about these technologies. In the data path, it means the service actually receives, inspects, and can manipulate the traffic. So you can see that this column where I've mentioned in data path, right? This tells you that these three technologies can manipulate the data on these layers. On layer 4, it can receive the traffic from on a different front end IP, and it can send the traffic and load balance it to different backend servers. L7, layer 7 is the application, the highest layer of the OSI model, wherein the product understands the application layer data, application presentation and session. It understands the encryption mechanism as well. It can do SSL offloading. If the traffic is encrypted, it can decrypt and send the decrypted traffic to the backend service. Same goes on with the front end. So that's what you need to understand. These technologies, they can deal and manipulate with the data which is flowing on this connection. The DNS doesn't deal with the data; it will just redirect the connection to the nearest point. That's the main difference you have to understand between these technologies. What is CDN? Content Delivery Network focuses on content delivery, not routing logic. Azure DNS CDN delivers content faster by storing caching your files on server around the world. So users get the content from the nearest location. So let's say if your server is hosting images and videos which your users are trying to access, right? Okay, there's a call to prayer here. I'll just pause for 2 minutes, and we'll complete this slide and we'll take a break. Let's wrap up here with this slide. So CDN is the content delivery network. You must have read the points already. So this diagram explains you what exactly it is. It's helping you with. You might be having your web server deployed in a specific region, and you know that your client base or the customers are mostly in a different region. So let's say you're in the East US region where you have the server running, the web server running, which has huge data. It will take time for your users or the customers to access and retrieve. So this is a very simple example. For example, here the user is trying to fetch the image from the server, which is in a different region than the client, and it's taking him around 120 milliseconds. Now, it really matters. The performance really matters. We are talking about milliseconds. The web browsing experience, it all depends on the latency, how fast the web pages are loading and the content is loading, right? So you can choose to deploy CDN, and Azure provides you an option to provide the CDN. So you might be having your server in a different region, or you can deploy CDN to the nearest POP. Point of presence is nothing but a POP that every cloud provider has their POP locations apart from their data centers. So, for example, they have this data center in East US, but in some location in the US, they might not be having the nearest data center. There you can have a POP. So they will have a POP configured. A small facility. They might be working with the ISP locally to deploy these POP locations. And you can choose a service, CDN service for that specific location and deploy your CDN service. So what does CDN service do? It will actually cache your frequently accessed data. If the user is accessing this image, let's say for the first time from the website, it is taking 120 seconds. It will be the same if it is accessed first time through the POP. It will take the same time, but in the next attempt, that content will be cached locally on the CDN POP with point of presence. So, and the next access to that file from the users in that location might be faster. So the images and the data will load faster. So that's the concept of CDN. I'll share the link again uh, with this concept on the lab. I think I have already put it here. If not, I will share it with you later. You can practice how the CDN can be deployed. Right. So let's take a break here. We have some important topics left. We can do the VPN. We try to cover the VPN today, and then wrap up our session today. Right. I'm taking the break now. I will be back after half an hour and continue the session.